We're here for our, I think, part 3 of this Holley 600 carburetor that New Guys Garage has provided us for testing. He's done a lot of the JB weld. We did that on our last video, and he's contoured the boosters. All the testing before was done with the 600 base plate. The difference on this test is this is a 850 base plate. We measured it just now. It measures 1 3/4 on each hole. So we're going to run this, see what it does. We're going to take you through running the master just to show you that our flow bench is still doing what it's supposed to do. The bench is a little bit happy today. This at 13 inches and 14 inches we're between +5 and +6 CFM compared to previous day. So last time we maxed it out at 12 inches. We're going to try it 11 inches. This is what it flowed the last time with a 600 base. This is a setup for our first round of testing. No spacer and all 4 barrels. This carburetor already outflows the flow bench, and when you do that, you can't test all 4 barrels to rated 20.4 inches of water. So we'll be doing some comparison testing at lower target values, and I will walk you through that in the later data review. So we don't want to push out any of our magic flow bench fluid, but we've already maxed it out at 11 inches. We tried to get a value by restarting the bench and showing you how much it's flowing as it's speeding up, and we're beyond 600 CFM. The bench almost catches a value at 10 CFM. We had to settle for 9.5 to get a stabilized CFM value. We then went to 9 inches and then mapped the curve all the way down to 5 and 1 inch increments. And because we were curious about booster signal and how it's affected, we mapped that out to from 10 down to 9.5, 9, and then in the 1 inch increments down to 5. We ended up measuring all 4 boosters on most of the set points. So we're going to try to do the spacer like we've done in the previous tests, but with this base plate it's hard to see, but there's significant overhang. I've had trouble getting the butterflies open, so we're going to test it like this. Not ideal, but it's the same base plate as previously tested. But even with the significant overhang on the spacer, to the point of the blades touching the spacer, we still pick up 3 to 5 CFM across the board at all set points. If the step was matched to the bottom side of this carburetor, it would do better. In this test, we're taping off one side of the spacer so that we can flow 2 barrels separate from 4. And the purpose of that is to be able to utilize the full rated flow at 20.4 inches. So once we get this bench to stabilize at 20.4, we're almost 20 CFM better versus the 650 base plate. In this test, we are noticing that when you're just shy of wide open on the throttle, your CFM reading on the flow bench is much higher. It's about 10 CFM higher, which is noticeable. So we've done this before with my 950, and I ended up putting a shim underneath here to have it less than watt. But basically what's happening is that the throttle shaft is becoming uncovered. I don't know if you can see that, the big rounded throttle shaft. If you cover it, that surface area kind of goes away and makes it presumably better for flow. So that's why we've seen a 10 CFM spike when we went a little bit less than wide open. We flip the spacer around so that we can do the same test on just the secondary side of the carburetor. So we are in full manual control with the secondary shaft, trying to find that sweet spot of the highest number. And we are almost up 40 CFM. All right, so this is one of those activities where we did what we could do with what we had, and showed you that it took very little resources for far as money to make it happen. New Guys Garage did an excellent job in showing the potential airflow of a Holley 600 main body, and I think that was the goal of this. In the big picture, iterations to this point on a functional carburetor would probably be ideal, just to guard against the fuel circuits not keeping up. But as we've shown, booster signal rising with airflow increase might not be an issue. Anyway, getting into some of the data, there's a couple things that I'm going to point out. We picked up 19 CFM just with the 850 base plate change on this iteration. That's on the primary, and we picked up quite a bit more on the secondary, almost 40, 39 CFM. And in comparison, looking back at our previous video, we're up 33 and 52 on both sides, just with the JB Weld and the 850 base plate. Now, practicality of the JB Weld might not be good for everybody, but definitely the choke horn removal is by far the biggest gain, followed by the 850 base plate. So if there's anything to try out there and people have that resource, that's definitely something. Getting into the booster signal data, I'll start by explaining how I have this laid out. So the before data is the JB welded 600 main body with the modified 600 base plate. The after results are removing the 600 base plate and adding the 850 base plate. So P is primary and S is secondary. This first one here, just for a frame of reference to the videos, this is the one that is facing closest towards the camera on the primary side. Same for this one, closest to the camera on the secondary side. So as you can see, more CFM with less pull. So the old 600 base plate maxed out the flow bench at 11 inches. The 850 maxes out 9.5. And you can see that the booster signal correlates. It's higher than previously, so we're flowing more air. Now, what's interesting about this first one here always seems to pull harder than the rest. The before data seems to be less spread out. If you look closely at the after data, the primary and the two primaries are just weirdly split. So what we changed was just the base plate. I don't know what would have made that, what may have made that spread better, other than the throttle shaft being stock with no grinding on it. Maybe the tapered spacer was fitting a little bit differently than the previous. But we can go all the way down. We measured all the way down to 7 inches with. What does this mean? It means that there's a chance that this will flow fuel. More CFM, higher booster signal. If you made it this far, thanks for watching. If you liked it, even better. Keeping my head down a little bit, because otherwise you're going to see something. You're going to see the reflection. So we do videos like this, or I put videos like this because it's a hobby. Blending two hobbies together has been something that I do when I have time to do. This one wasn't as timely as it could have been, but hopefully there's some value in it. please comment if this inspired you to try some stuff. Not everybody has a flow bench or fancy ways of measuring flow at their disposal. My friend Josh owns the flow bench, and he uses it for his business, for his fuel system development projects. And he just lets me use it when we have some interesting things to show. So we'll probably end up using it more here and there. It's not something that we're on all the time. We have other projects and things to do. Some that we don't film because it's maybe not interesting, or we're in a hurry to get something done. But leave a comment and what you like, if it inspired you, if you've tried any of this stuff before. It's kind of cool to hear from other people too. So thanks again, and thanks for watching.